So how many of you guys have ever done anything with chromatography before? What did you guys do for chromatography?
Markers, permanent markers.
Just with like coffee filters and.
We had some chromatography paper, but I didn't really see a whole lot of difference between using it and the coffee filters. So, you know, I'd use it with polarity.
Okay, great. And then what did you use, Britton?
We also use permanent markers.
Okay.
That was back, it was one of the college courses I took. I haven't actually done it inside of my own classroom yet.
Okay. Do any of you guys use it during photosynthesis or anything to show?
Yeah, that's what we do. We take different kinds of leaves, and I found that beet leaves work really, really, really well. And you can usually get those for free. And because the grocery stores will, just go steal a couple, borrow a couple. And yeah, that's what I use it for. And I use filter paper because it works better. Chromatography paper because it works better.
Chromatography works better for you than the filter paper?
Oh yeah, definitely, because the separation is crisper.
Yeah, I know we use it in photosynthesis and stuff. And then I've actually started doing this chromatography lab with my bio kids when we talk about polarity and then also relating it to the cell membrane. It helps a lot. So do you guys have, let's see, you guys have the directions for I gotta flip back, for the chromatography in front of you? It tells you to prepare a 25% isopropyl alcohol solution and a 5% isopropyl alcohol solution. And these directions actually give you everything that you need to do that. But I want to, and hopefully you guys can see it okay. Are you guys all familiar with the equation C1V1? Is anybody not really familiar with it? So I think Megan had said at the last Zoom that you didn't really need to make 500 milliliters of 25% alcohol. You just need about 100 milliliters. So I wanted to show you guys, if you use the equation C1V1 equals C2V2, can you guys see that?
I was trying to do that earlier, but I had it as fractions. That's what I did wrong.
So the C1 is like the initial concentration of the alcohol. So the stuff that Megan and Kristen said was 70%. Okay. And then what we're going to be solving for is the volume of 70% alcohol that we need to make a 5% alcohol solution of about 100 milliliters. So if you solve for V1, you should get about 7 milliliters of isopropyl alcohol. And then that would be, I think one of the things that kids do incorrectly is this is 7 milliliters plus 93 milliliters of water to give you a total of 100 milliliters. Okay. So that would be our first volume. So do you guys want to take a minute and make your 5%, like 100 milliliters of 5% alcohol? Okay.
Sure. And then we need to, do we still do the 25% too?
Yes, you'll still need to do the 25%. I'm going to have you guys work that out and tell me what you got on that one.
35 and 35.7.
Yeah, and I rounded up to 36.
Okay.
I feel like the chromatography stuff's a little bit forgiving, so I did 7 and 36.
So I'm sorry, I walked away to get a couple of beakers. 36 milliliters into 64 gives us 100 milliliters of, where's that 36 coming from?
The 36 is for the 25%. If you do the same equation, except change this to 25, then you should get the volume 1 equaling 36 milliliters. So for 25% alcohol, you would take 36 plus 64 water.
And we're going to put those in the containers with the lids, right?
I think you're supposed to have some beakers or some kind of containers that you can put them in. And Megan,
Yes.
They had sent a graduated cylinder. So for the first solution, you would just go up to 7 and then the rest of the way to 100 with water.
And yes, that's the little containers I had everybody get. So you can use beakers, or if you have the little, like, yeah, I saw somebody hold up the plastic containers.
Oh,
Something with a lid, because alcohol does evaporate. So you can keep it for later as long as it doesn't evaporate. And Trisha, will you adjust the focus on your other camera? It's
Which
pretty
one?
fuzzy.
this one,
Yeah,
it's not good.
it's a little fuzzy. That's better. There you go. Yeah,
Okay.
perfect.
It's hard for me to tell on the little square.
Yeah. Well, and then on our end, we can kind of click on you and then say pin video. And so now you're my entire screen and I see everybody else on the side.
Aw.
Yeah.
Does anyone have any questions about the math or about making the solutions right now?
No, but thank you very much for fixing. I'm going to write that on a Post-it note and hang it up so don't forget.
Yeah, one thing that I like to do is ask the kids, like, if you had 100% alcohol and you wanted to make 70% alcohol or 50% alcohol, what would you do? And they usually come up with the fact that you would just dilute it to 50% alcohol, 50% water. You know, and it's easy when you're looking at these equations. I mean, the numbers make sense, you know, if you only want a 5% solution, it would make sense to use very little alcohol. So you can kind of tell if the kids are getting weird, large numbers, or then they're not doing their math right. I guess let me know when you guys are ready, and then we can, this lab, I feel like for the most part, you have to stick to the directions because it starts with prepping the chromatography column and it ends with prepping it so that you can use it again. So I feel like following these directions in this lab is important for the amounts. Okay. Do you guys all have the books open or the lab? It was on page 19.
Yep, I'm good.
Okay.
Oh, and I had storage instructions for the columns, and then I thought I put that in the binder and I didn't. So I'll make sure that's in the folder for everybody.
They are actually in the tips that are after the disposal part on the back side. It tells you to re-rinse it with the alcohol in the water.
Yeah, well, I typed up a separate kind of like care thing Because I flushed it not only with the 25, but like with higher percentage, like the straight 70% before storing it. So
Okay.
yeah. I thought I included that as the back page of like that lab report, and it's not there. So.
Okay.
Oh, but it is in the folder. So there's a document called maintenance information.
Okay. All right.
Yeah.
So we did some of the preparation. Step 3 of the preparation asks you to make the Kool-Aid, the purple Kool-Aid solution, and that would be 0.3 grams of Kool-Aid per 100 milliliters of distilled water. Now, I've never used distilled water because tap water is free out of the tap. It's always worked. So that, I guess that's one thing. The tap water's worked fine. So, but if you guys could take a minute and make sure to have that Kool-Aid solution prepared, 0.3 grams per 100 milliliters.
I
think I mentioned it.
Half the packet in about 100 milliliters of water.
You did half the packet?
Yeah. Ish.
Oh, wow. And it worked?
Yeah.
We
I just added-
overloaded. We
I,
overloaded one. I'm sorry, Stephanie, what?
Just added some.
Okay.
Yeah, some. Rachel's holding up
We'll see what happens.
you
I was
already
telling my kids about it, so I went and grabbed one of our strips of filter paper and just stuck it in the Kool-Aid
Oh, nice.
so they could see it. They always are excited when I start setting up whatever we're doing, on these nights. So I get to give them a little preview.
When I give my students this lab to do, I just set it, I have it like set up as part of a sheet where it tells them what to do, but I have them like guess what color they think's gonna come out first. And I usually do purple first, but then we always, we'll try the orange Kool-Aid and the green Kool-Aid, and I know they sent you guys a pack, but it would be really neat to have kids do different Kool-Aids, and then you could go through and figure out like which molecules were more or less polar with all of the chromatography data.
That's
So
cool.
yeah, it's pretty neat. The kids like it. So do you guys have your purple solutions, Kool-Aid solutions? Okay, super. And in the procedure 1, I mean, you guys can read it, but it says basically put 70% alcohol into the syringe and then plunge the 70% solution through. And one thing, if you've not used the columns before, to be conscious of is like, once you put the purple solution through and the color is in the chromatography column, that you're always going to want the students to like take the plunger off or take the column off and then take out the plunger and put it back on, or it like re-sucks up stuff the wrong way in the column. Like I always have to remind them because they start pulling plungers out all over the place. But it says 10 milliliters of alcohol and flush it through.
So the way I did that was I didn't have the C18 on the syringe. And so then I used my syringe, just, pull it up, and then I put the filter on there. Is that going to be a problem?
That's what I do too.
I kind of like your way, you know, because if you think about it, like with my AP kids, I get them to try and hold things in one hand.
Oh, that's
know?
good.
So, because we use the Lamont kits, the DO kits and stuff. And so I teach them to do this for contamination and not losing it. And so I like the way you did that.
Okay, wait, try one more time. I just sucked it up, right? That's all you do. And then you put this on there?
The doohickey. I know it says it's a C18, but I really think it should be called the doohickey.
I like doohickey.
So then I squirt this back out?
Yes.
Okay.
And it's a little tough sometimes to push the stuff through the column.
Yeah, I feel like especially when you're priming it, because you got to get it in there. And then once it gets liquid in, it's a little bit easier.
And once you have run alcohol through, it tells you to repeat step 1 using 10 milliliters of distilled water. So then you're gonna, whether you take it all apart and then put the column back on, or you just take the column off and suck up 10 milliliters of water, you're gonna get the water in and run the water through. And then it says place the 6 well plate on the overhead and pour grape Kool-Aid into one of the wells. And so if you guys have your grape Kool-Aid, we can get it in.
Oh, 10 milliliters is too much.
So this well does not hold 10 milliliters. So I just, earlier, I just poured 10 milliliters directly into the syringe. And it worked fine. So I guess either or, but it asks you to remove the cartridge in the syringe and draw 10 milliliters of the grape Kool-Aid into the syringe.
All right. So just put the grape Kool-Aid into the well. It doesn't matter how much.
Well, the well doesn't hold 10 milliliters. So,
Okay.
So that's why I just poured 10 milliliters directly into the syringe, like I was doing with the alcohol and stuff. And Megan, did you use all 10 when you did it?
Yeah, I just pulled the syringe up to 10 milliliters of Kool-Aid water.
Does everybody have it in?
Yeah, so I don't know if you can see this, but 10 milliliters in my syringe. Look how cool that is.
Yeah.
Yeah.
Fills up 1, 2, 3 and a half of the wells on this 24 well plate. So like, I don't know if that's going to make a
I think,
difference or not.
yeah, they're about 3 milliliters maybe.
Yeah. So, but it doesn't matter, right?
Okay.
How many we make, as long as they can see.
So it's
Right.
That is pretty cool. I must admit, I like that.
Yeah, there's a different version of this lab that I have where you use a little less Kool-Aid and you use only 5 milliliters of it. And when the kids first run the purple Kool-Aid through the syringe, their first test tube that they put it in, it's all clear. So all the color is stuck in. But I just ran my purple through, and you guys can see I have some pink here. And then what you're going to do now that the Kool-Aid is in is now you're going to run the 5% alcohol through until it's clear or close to clear. And then you're going to run the 25% alcohol through. So 10 milliliters at a time.
Will it take more than one syringe full?
Earlier when I was doing it took, I think for the 5, maybe I did 2 of them, 2 syringes. And then you can just put the solution in the wells.
So I bet you could do this. Like, what's the point of the wells? Could you just use like little Dixie cups?
Yeah. I just gave you
Medicine?
well plates because that's what we had a lot of. And I like the well plate.
Yeah,
So
Megan, well crates are pretty.
First I was red, then I was purple, now I'm blue. I'm not doing it wrong, am I?
So the red should come out first, and then by the time you get kind of end, it should be clear. So this is where my 5% went in, and then now it's about clear. It's about, for me at least, it was about 2 syringes, about 20 milliliters of 5%.
I'm blue. I wonder if I just messed up on my
I think I did
making
mine wrong too. Mine's blue by the time I get to the end.
Right, there's the blue in the or there should be blue left in the chromatography column because you've pushed all the red out with the 5%.
All right, I'm gonna see if I can. Can you
That's
see
the way
that
mine looks. Yeah.
mine started out red, but then as I kept pushing, the water turned blue.
Did you?
I thought it was supposed to be clear.
It got clear for a while and then it started to turn red, or
It
blue.
was still.
Maybe I did have y'all put a little too much Kool-Aid in there.
Okay.
No, did you do the water, Stephanie? Did you put the rinse the water through?
Yeah.
Huh.
Mhm.
Well, and yeah, when you run the 25, it should be a lot more blue than what you were seeing.
Okay.
So there's
try the
probably
20.
still some blue in your column.
Yeah.
Yeah, earlier when I did have a tiny, tiny bit of blue, but then it was like, then it was super bright blue when I did the 25%. But Megan, I think these well plates are super neat on white paper because they get to see the, as you go through and push the alcohol through,
Yeah.
the color change and it gets clear.
Yeah,
in
I
the
like that
past,
well
I've had
size.
kids. It's perfect. And I'm at the end of my 25,
Look, how blue.
Yay.
and all my row is clear. Is everyone getting red and blue?
Got red, then purple, then blue.
I did, but my colors are definitely a lot brighter than yours. But they did go from kind of clearish pinkish to red and then to blue. I don't know how
Awesome.
to show you.
Pictures on Group Me.
Yeah, you
Oh,
can
yeah,
take a
that's a good
picture and
one.
put it, yeah. Share-a-thon.
So do you guys have any questions about why the red comes out first compared to the
Yeah,
blue?
go ahead and explain that. How'd you guess?
So, like we always, I don't know. I always talk about water and how water is polar. And then we talk about how if we make an alcohol is less polar than water. And if you make a 5% alcohol solution, I try to put it on like a spectrum. Hang on. Let's see if you guys can see this. So if this is like here, most polar would be the water. And then here, least polar. So, we just kind of have a conversation about which solution, 5 or 25, is more polar. And they always, the 5% is closer to polar than the 25%, right? Does that make sense? Yes. No? Okay. And so then we talk about, well, which color came out with the 5%, and that would be the red, and the blue came out with the 25%. So then we talk about the red molecule being more polar, the red coloring. And if you look at the information that Megan and Kristen gave you, it says the set pack C18. So the chromatography column itself is very non-polar, which if you guys remember, like likes dissolve likes, right? So the chromatography column is going to hang on to the more non-polar molecule, which is the blue longer. Does that help? Or does...
Yeah, I mean, I get it.
Megan, is this something that you have a lot of at the equipment depot? These like CPAP packs?
So I don't have a lot of these, but we order them from a company called SorbTech that's local, that I get them in packs of like 50. And you guys need like a class set of 8. So I can order those for you. I think I have some right now, but not enough to like send everybody a class set. But yeah, so if that's the lab that you want to do, I'll make sure that you get them. And this company, they're like $2 a piece, as opposed to Flynn sells these for like $11 a piece.
Whoa.
So we can get you some, and then you don't pay anything for them. So.
And these colors are a lot brighter than the Flynn ones, because I had the Flynn ones until I got these from Megan, and these colors are way more vibrant than the ones that we got out of the Flynn ones. So. But this well plate is awesome. If you don't have the well plates, test tubes with a white background also look really neat. And like we kind of talked about last week, just letting the kids explore a little bit. You can follow the same exact procedure with the orange and the green. It works out just fine.
So the columns are reusable? They are.
Yes.
Do you have to prep them again before you use it?
So you,
So-
there's a thing in the folder on the Google Drive in session 3, there's maintenance information. So this tells you, I think, to just flush it with like the 25%, but if you flush it with full strength isopropyl alcohol, you can store it after that. Like they'll dry out on their own, or you
Okay.
can just reuse it again with the next class, like prime it again and then
Okay.
use it. Yeah.
And then this actually says the 70% and then distilled water afterwards, but I feel like I've only ever had them put concentrated alcohol through to clean them. Did you ever put water in yours after the alcohol, Megan?
I think I just rinsed it with the alcohol because that's what I did in lab too. Like we just always dried the columns with alcohol. So
Yeah, okay. So if you guys want to take a minute and run some 70% through, it should clear up your anything else in your column. And occasionally
leave-
mine don't look as white.
yeah, it might leave a little bit of a line, but it's not enough to affect the next time you use it.
I was like using some muscles, getting that in the sink. Okay. Do you guys have any questions about the chromatography?
So can you give me an example of where I would use a setup like this in biology?
Well, I think I'm more familiar with the AP biology standards, you know, and you are too, Stephanie, right? Like there's
Oh,
the
no, I don't teach AP
properties of
bio.
water. Oh, I thought somebody said they did.
I teach AP environmental, but not AP bio.
Oh, okay. So maybe before macromolecules and things like that, like if you do review a little bit of properties of water, when you talk about the cell membrane and, you know, small non-polar molecules being able to cross the cell membrane more easily through diffusion, you could relate this activity to that a little bit. With the polarity and the non-polar molecules.
And I was thinking also, like, if you're talking about environmental science, and I don't know what the AP environmental science standards are, but like if you were just gonna like talk about pollutants, different pollutants that would elute at different fractions, and just kind of say like, could you identify what the pollutants were based on their polarity, something like that.
We did a lab when I was in high school with, and I think she mentioned it, with leaves and doing the different colors.
So I wonder if that would work to take spinach or the beet leaves and I don't know. What would you soak that in to get would you put it in alcohol? Would that work?
I mean,
Just
maybe in
open-
water, but just make sure you strain it really good before you put it in the column,
Well,
like run it through cheesecloth.
okay.
Yeah, I haven't put
You could take
actual.
purple cabbage and do it with that, couldn't you? You know, just blend
What,
it.
Stephanie?
Nothing. Sorry, I'm just thinking out loud. Don't pay attention to me.
Yeah, if you let the you know, just like the spinach leaves and stuff, just letting them sit in water for a day, the water is usually pretty green afterwards.
Okay.
You guys okay?
Does the force or like the amount of force you use to push it through the column, does that affect how fast or slow or how well. Like Britain's, like you've got a lot of colors there. I do not have that many colors. Am I just, so I'm wondering if I'm like squeezing too hard.
I couldn't tell you how hard I squeezed it, to be honest with you.
So Rachel, I think yours, maybe your Kool-Aid solution just wasn't as dense as Britain's.
Concentrate. Okay, so concentrate.
Yeah, concentrated.
Okay,
Yeah,
gotcha.
that's what that looks like, because your purple isn't really too purple.
Yeah, it said to do it like it said prepare it like you would, and it's 2 quarts, and that's 18, almost 1900 milliliters. So, you know.
Well, and I only ever did it because I don't have a scale like that at home. So I just dumped in a portion of the packet and some water and mixed it up until it looked not drinkable.
And I feel like with the old, like the Flynn ones, I feel like one year I had a class, they put like 2 grams instead of 0.2 grams, and it totally bogged down and overwhelmed the set pack. But clearly with these, it doesn't seem to matter.
They're pretty forgiving.
That's good.
Yes. They are lovely. Yeah, Britton, that's really cool. I like
Yeah.
yours. It's a lot of nice colors. So I guess if you guys don't have any other questions about chromatography or this Kool-Aid chromatography, we can start looking at the gel electrophoresis lab, which is, I think it's going to take us a little bit to finish. So Megan and Kristen sent, are you guys ready to move to gel electrophoresis?
Finishing cleaning the column.
Okay.
I'm ready. So we're not going to, excuse me, we're not going to need our diluted alcohol right now, are we?
No.
But you can put the lid on it, put the rest away, and use it again later.
Right.
So is there anybody that has not run gel electrophoresis before?
I have.
Okay. So this kit that Megan and Kristen sent is pretty awesome. So with gel electrophoresis, can somebody explain what it does?
Well, with DNA, it separates, I know it from DNA, but it separates the DNA fragments by size. And then you get a banding pattern that's unique to an individual.
Correct. So because of the properties of DNA, one of them being the fact that DNA is negative, if you extract DNA and you can put it in gel electrophoresis, then it will run, the DNA will migrate from the negative end of the chamber towards the positive end of the chamber, because the negative end and the negative DNA repel. Okay. And what Stephanie was talking about was the different fragments. Like there's lots of different things that you can do to cut DNA into pieces using different enzymes, et cetera. And then if you ran somebody's sample and somebody else's sample, you could use it for like crime scene explanations. You know, these fragments matched the crime scene, so their, you know, blood or whatever was found at the crime scene, or you know, their oils or hair follicle or whatever. You know, you can talk about it in terms of evolution, like organisms that share the most bands might be the most closely related because they have the most DNA in common. There's a lot of different times it comes up. Or you could use something like gel electrophoresis. Like in ecology, you can set up a lab where you have maybe different colors represent different organisms, and then each part of the gel, like each well that you put the DNA in, could be a location that you take DNA samples from to see if there's invasive species present. There's a lot of cool applications that you could take to implement gel electrophoresis in a lot of different classes. So
HHMI has this thing where this guy's doing this research about which organism is eating which grass. Like he's got the zebras and the other little deers and the other herbivores. And so he takes their poop and looks at the DNA looks at his poop to see which grass that one is eating. And so you can actually time the appearance of the animal with the new growth of the grass that it eats.
that's cool.
Right. It is pretty cool. So, you know, you could probably do something like that. If you get this band, this animal's eating blah, 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 which anyway, I could see me doing an inquiry thing like that.
So the lab setup, we probably need to make sure that we get started. You guys are all supposed to have a hot plate or microwave or something for making your agarose. So Megan sent 0.8 grams of agarose in a little centrifuge tube. Okay. Most stuff with gel electrophoresis, you basically want it to be what we call like a 1X. So you have 0.8 grams of agarose, and you have a tube with 50x TAE buffer. So hang on. So for making a gel, agarose gel, you need the agarose powder, you need the TAE buffer, and you need water. So I'm not sure where it is in the directions, but if you have 0.8 grams of agarose and you put that into 100 milliliters of water, what percent is that?
0.08?
Well, it should be 0.8, right? Because 1 gram in 100 milliliters
Is 1%.
is 1%. So 0.8 grams would be 0.8%.
Right.
And for most of the labs that any of us would do in biology, environmental, AP biology, either a 0.8% gel or a 1% gel is what the directions will call for. Okay.
Well, and my intention was that you can make a 1% like 0.8 in 80 milliliters.
exactly.
So yeah, 80 to 100. But I think they hold about 70. So that'll give you a little like leeway.
So, depending on the equipment that you have, like these trays that they sent, I had put, the 0.8 grams that Megan sent and about 80 milliliters of water in the flask and heated it up. So I have a 1% gel in here and I have some left over in my
To the buffer, how much of the buffer do we want to put? Don't we have to put buffer into that 80 milliliters?
Yes. So yeah, thank you, Stephanie. I'm sorry. It's been a long day. So the TAE that you guys received is labeled at a 50X. So like it's a 50 concentration. Okay. And like I said earlier, typically we want everything to be 1X. So if we're gonna put 0.8 grams in 100 milliliters of water, how many milliliters of the 50X would you add?
5. Yeah. So 50 over 100 gives you 50%. Oh my God.
And again, you guys can use the C1V1 equation. So 50X initial concentration times our V1 equals 1X times 100 milliliters. So 100 divided by 50 would be 2. So V1 is 2 milliliters of our TAE.
That wasn't even close.
You guys okay with that?
And you can get the buffer out using your one of the plastic pipettes, since they have labels at 1 and 2 milliliters. So you can just draw out 2 milliliters of buffer in the pipette.
So
That's 100 milliliters, right?
So in whatever glass container you're gonna mix your stuff in, you can pour in the 0.8 grams of powder. You can put in 2 milliliters of the TAE. And then you can raise the total volume up to 100.
Wait, did say that again?
Wait, put the TAE in first before you put the powder in.
And
right.
what? Where am I putting this in?
Badge red cylinder.
You can use your plastic beaker. So plastic beaker or a glass beaker.
I'm gonna have to, is this what I'm gonna have to heat?
Yes. So whatever you're gonna heat, I would pour the powder in, and then I would put the 2 milliliters of TAE buffer in.
So the whole agarose, right?
The whole tube of agarose.
And 2 milliliters of this.
Yes.
And then
And
milliliters of water.
about 98 milliliters of water.
98. Okay, because we did 2 of the buffer.
Yeah.
So fill it to the 100-ish line.
And then as soon as you guys have that mixed, whatever you're gonna heat this on, if you're gonna heat it on a hot plate or you're gonna heat it in a microwave, this is where I would strongly recommend safety goggles, just to follow safety procedures, because when you're heating, if you're microwaving agarose gel, it probably won't take more than a minute. And if you're microwaving it, pressing start and letting it run for maybe 15 seconds, stopping it and swirling it, because agarose will flash boil, just like agar does. So anytime I have my students making anything, it's just 10 to 20 seconds at a time and swirl. And you basically want to heat it until the liquid solution is clear. Does that make sense what to do?
Yep.
Heat it until it's clear.
Heat it until it's clear. And just small little increments. Or if you're using a hot plate, you know, you just have to watch it because it will start to boil, and it will start to boil very quickly.
Once it starts to boil, you got to get it off.
Once it starts to boil, then you just like watch it and kind of swirl it. And if it becomes clear, if the liquid becomes clear, then it's ready. So if you guys want to get your agarose made,
How long do we have before it actually solidifies as a gel? Like once we heat it up and get it all clear, is this like a race against the clock thing to get it poured into whatever we're pouring it in?
it is definitely not a race against the clock. It will stay liquid for a little while. These dishes, I just poured it in when it was pretty warm. But if you have at your school, if you have like actual gel chambers, gel equipment, or if you if you borrow any from the depot, you're going to want to wait till the agarose cools, till you can, like, it's still liquid, but you're comfortable touching it with your hand. It's like 55 degrees. Because if you pour it in what you would rent from Depot, you would crack their materials. It would start to crack and like fissure.
So you do stir it while you're heating it, right?
You can stir it. You can just kind of like lift it up and swirl it around.
Why do you do it in an Erlenmeyer?
I always microwave it. So I don't know. I just always grab the Erlenmeyer flasks. I don't know. I could do it in a beaker.
Isn't that a safety thing to do it in an Erlenmeyer? I thought.
I mean, with the flash boiling, like I feel like it kind of keeps it less likely to.
Tamed?
Yeah.
Yeah. Okay.
And my kids, like, this is the perfect size little Erlenmeyer flask. So the gels that my students make, we just make 50 milliliters of the 1% agarose gel. And these are the perfect little size, and they're quick to heat and become clear, and they're quick to cool.
But we're making the 0.8%, right?
Basically, by adding just the 0.8 grams to basically 100 milliliters of water, you're just making a 0.8% gel.
Okay. What does the buffer do?
So the buffer, which stands for tris, acetate, EDTA. Yeah.
Done.
So the buffer helps maintain pH. Like the tris part is, I think, the base, the acetate is an acid, and the EDTA actually helps bond with some of the other things that might interfere with DNA as it migrates down the gel. So so we add buffer to the actual agarose gel, and then in a minute we're also going to add buffer to the buffer that you're going to make and pour on your gel.
The microwave is downstairs. Am I gonna miss anything if I run downstairs and heat it up?
I don't think so. The only thing that I wanted to add was, like Megan said, what what she has provided and what the little tray holds is a little bit extra. It's a little bit like you don't need to use all of it. And so I don't know if you guys can see it very well. I have the wells, like I poured the gel and then I put the wells in so that there was still a little bit of space. I don't know how to describe that very well. But if you pour all of the gel, the agarose gel in, it'll be a lot higher on this comb. Does that make sense? So if you pour the agarose about halfway up the container,
Yeah.
it's about perfect. And then as soon as that, you guys can pour it in the container when you guys are ready, about halfway up, and then you can stick the comb piece in, which is a version of this. You can stick the comb piece in, and it needs to be perpendicular to the bottom.
I still have my little prototype sitting on my desk. I made these out of craft foam. And then Janet Standevin's students took my little foam prototype guy and 3D printed the ones that you guys have.
That's awesome. So I guess as soon as you guys have your agarose poured and the comb in, you just want to make sure the comb like stays perpendicular and doesn't flop one way or the other. You guys can start getting your candy ready. And in order to get your candy ready, like the little medicine cups, you should have 4 of them. I think I had 4, and then I picked 4 Skittle colors. And then Megan had pre-measured out some dye extraction solution. And if you just could pour a tiny bit of that dye extraction solution in each of your candy medicine cups.
Yeah, and if you want to be exact, there's 2 milliliters worth. So on the plastic pipette, that first line right under 1 milliliter is for a 1/2 milliliter. So you can just put a 1/2 milliliter in each cup and that'll divide it evenly.
And you guys should also have some yellow, blue, orange, and red dyes in a smaller tube.
Okay, so once it's clear,
Yes.
then we pour it into the gel thing.
Yes.
Each box.
Your goggles are awesome.
This is so I can tell mine from the kids. Like, don't touch those. So mine didn't boil, but it got clear, and that's okay, right?
It should be. I feel like mine usually boils some and then it turns clear. Were you microwaving it or on a
Hot plate.
So yeah, I mean, I don't remember on a hot plate.
Yeah, I mean, it's probably
Okay.
fine if you don't see anything in there.
I don't. I don't see anything in
Anything like any of the agarose powder, like just as long as everything is dissolved, it should be fine.
there. It's kind of like bubbly. And it's kind of like jelly. It's supposed to be like scraping it off the bottom.
So if it sits too long, or maybe because it didn't boil, it would probably start to solidify faster because
Okay.
the temperature is cooling.
Okay. Well, maybe that's what this is.
But as long as you have enough, liquid to pour about halfway up that little box.
Right. Okay. All right, and then
So does everyone have their gel poured and waiting for it to be solidified?
Do.
Okay, and then does everybody have their little, their Skittles with the color being extracted?
not yet. How did we decide to do that?
So Megan had sent the little, medicine cups. And she sent a little tube that says dye extraction solution.
Okay, there are 4 of those. Is that right? No, this one. Okay.
And then if you just want to pop one piece of candy in each medicine cup, and Megan said that 2 milliliters of the dye extraction solution, so you could pour about half a milliliter in each tube.
Yeah,
And-
so use the plastic pipette. The first line on it represents half a milliliter
And where am I putting that? I'm sorry.
in each cup.
With the Skittle
Yes.
or with the, I don't know what. No. Already fell. Skittle on the ground.
And I believe it says it in this lab, but your students can pick different candies. I was running through this at home, and my daughter that was 6 grabbed all kinds of candy and was throwing it in cups and looking and seeing if it dissolved. And the dye, I thought I saw a question, about the dye extraction solution.
Yeah, I answered. I think Lee from Biorad said that it's PBS, I want to say. So, yeah, but I think buffer would work too.
Anything, and even a little bit of, what were we talking about? Like some kind of like cornstarchy, sugary something, because all you want to make sure you can do is keep the dye down into the well. So anything that will hold it down in the well, and that doesn't have a charge, like a sugar solution might work. And Flynn has a kit, like an electrophoresis kit. It's called like a process to dye for, DYE, dye for. And it comes with all kinds of charged dyes. And so in a second, when you guys are loading some of your stuff, I was gonna load a gel with some of the dyes so you guys could see, because the dyes will actually migrate both positively and negatively. So where we put the well plate up near one end and we're counting on the negative charge running it, if you prepare a gel and have the wells in the middle. That'll allow certain dyes that have, you know, positive or negative charges to migrate both ways. And it's a good conversation piece for like regular bio and things like that. But it's a process to dye for. But I think you could just order any kind of dye. Like I have a list of dyes somewhere that I'll have to get Megan. Do you guys have any questions right now? So since I can't see everything, everyone has their colors ready. And then are your gels starting to harden? Some yes, some not yet.
I'm just now pouring mine.
Okay. There's your cat.
Yes, he is in the way quite often. He's lovable, but he's in the way.
So I guess while you guys are waiting for your gels to solidify, we can go ahead and start making the buffer solution. The buffer solution that you pour on the gel just also needs to be made into a 1X. So if you need, I don't remember what the directions were actually. Like, let's say 50 milliliters of 1X TAE. Oh. I'm gonna have to, let's see. Okay, guys. So if we have, did someone have a question? I thought I heard something and I wasn't looking. Okay. So again, if our initial concentration of TAE buffer is 50X, and we, for this, need to just make maybe 50 milliliters, then we could do C1V1 again for 50 milliliters, and 50 divided by 50 would be 1, right? So we would use 1 milliliter of TAE, and then we would add that to 49 milliliters of water. Are you guys okay with that?
What
Is that
did
how
you
much we
do
need to
with-
make?
I didn't remember how much you actually have to pour on. You need to pour enough that it's going to fill in the spaces that we're going to cut, and that it covers the gel. And I figured 50 milliliters was safe.
What did you do with the colors? Because mine are still in like the little tiny cylinders.
Oh, the ones that are in the tubes, leave them for now.
Okay.
Yeah. So you will load them into your gel in a little bit.
Britton,
But do you have your Skittles?
What am I doing with the Skittles?
What do you do with the Skittles?
Yes.
So you can pick 4 of the Skittle colors and pop them in the cups, the little medicine cups that were sent. And then you can take about 1/2 milliliter, a half a milliliter of the dye extraction solution. Megan, do you want to show the pipette?
Sure. Here's the plastic pipette. So this first line is 1/2 milliliter. So there's a line that says 1 milliliter. So the line under that is 1/2 milliliter.
And
And it goes up in half increments
And I'm doing 1/2 milliliter into each
into each cup.
M&M cup. Okay.
Yes. And like the beauty of gels, guys, is that if something happens, like if they crack their gel or whatever, before you use it, if anything happens to it, you can just reheat it and re-pour it. You don't have to use more powder or buffer solution or anything. You just cram it back in the flask and reheat it and re-pour it. And then if you guys want to, while we're waiting on a couple of things, if you guys want to make sure to grab your, you can grab your micro pipettes that we use during pipetting, and you guys can grab some tips. And what we'll typically put in the wells is if you want to get your micro pipette set to maybe 10 to 15 microliters.
So use the 20 microliter one.
For well size. Oh, you're
Yeah,
talking
they
about
have a
pipette.
20 and a
Okay.
200. So I'd use the 20. It doesn't get enough love.
Do you guys have any questions about how to reset your micro pipettes?
I have mine too. I feel like I'm hoarding,
Are you
have
doing-
all this stuff at my house.
And guys, as soon as your gel looks like it's kind of like this, like, you know, I guess like opaque-ish looking, and if you kind of feel it and it's solid, then you can get ready and you can take out your comb.
Okay, how many microliters?
I feel like about like the size, I feel like you'd be safe with 15. Is that, how many did you pipette in, Megan?
Yeah, I do about 10 to 15. And then the little reference dye tubes that you guys got, I put in 15 microliters. So you may not get 15 back out, but you can set your pipette to 15 and then kind of draw around in the reference dye tube to get out what you can.
So I guess when everybody's gel is ready, let me know. Does everyone have their colors? And are we waiting on anybody's gel to solidify? Okay.
Mine
Steve
hasn't.
Britton.
Rachel, did you say yours is or isn't?
Hasn't. It's not quite there. It's jiggly.
Okay, so I think we're waiting on a few then. Do you guys have any questions right now? No?
So can you offer an explanation of why some of our gels are taking so much longer? Like, I feel like this is taking longer than what it normally does for me. Did I not heat it up enough?
Like, I don't know with Rachel's, you know, because she said hers never really boiled.
I
know-
use the microwave.
I feel like mine took like 20 minutes or something. I feel like it took a while for it to solidify.
It's getting
But
hot
eventually
outside.
it will.
But eventually it should.
Okay, well, don't wait on me, like I've done this. So, you know, I can catch up.
Okay. Britton, you still need yours, right?
Yes.
Okay. I think we have, Megan, do you think we have time to wait just a few more minutes for people's? Or you
Yeah.
want- oh,
Well, and you guys can leave your setup going after the class is over too, if you want, so.
Yeah,
Did
I
everybody-
think I would be okay as long as I can watch what you do.
Yeah.
Okay.
And you guys made your buffer?
Yes.
Cool, cool.
okay. Give me 2 seconds. Okay, so are you guys okay if we kind of talk about the next steps and then we can work through it? So the directions for this, if you flip to page
56 and 57.
that sounds close. That sounds close to right. You should have 2 paper clips. And on page 47, it tells you to make this like boxy U shape with them. So if you can bend them to form that U-shaped, that would be then one of the next things we need to do. And then on page 55, it shows you directions for kind of like measuring your little chamber. And so if you guys have some kind of knife, or in the picture it shows a ruler, but you basically need to cut a little bit off the end, each end. And then pop the piece that you cut out.
Oh, cool.
Huh, I never cut it, I never popped it out.
Didn't it?
It ran just fine with it still in,
Okay, well,
that works.
maybe don't pop it out. I guess it doesn't matter.
I mean, that probably works better,
You
because
can
that,
see the bubbles.
yeah,
So I popped out 2 thin pieces. And guys, the kids love the way this stuff feels. Like they love it.
Yeah, and then we should just put that extra back in our Erlenmeyer, correct? And use it for next time.
You can, I mean, you know, you can pour a gel and then you can save it like in a baggie or anything like that. And these are really nice because they're just automatically closed up. And they should store for a little while. I would just wait. I don't know how long these would last in here, like as water kind of like evaporates out of them. But so does everybody have a little cut or slice popped out?
All right, if it does okay in the beaker, it should be okay in the box, right?
Yes. Is yours solidified like your extra in the beaker?
I was able to cut the chunk. And it looks pretty good. I think so. Looks good.
Okay.
Um,
So I've, one training that I went to, there was a guy that actually loaded the samples in these wells before he put the buffer on. And it seemed to work well for him, but I've always poured the buffer and then put the samples on. So I don't know how risky you guys want to be tonight. It's a Wednesday, March 24th, you know. I'm gonna go ahead and I'm gonna pour buffer on my gel enough to fill the end spaces and cover some on the top. And I actually used about 40 milliliters of my 50.
all right, so, oh, shoot. Okay, so pour in the buffer so that it fills in the two ends and covers the top.
Yes, I mean, I don't know, maybe like half a centimeter or a centimeter of space here that there's not any liquid. I don't know how to maneuver. I don't know how to maneuver this to get that angle right now. And then
So it's supposed to cut, okay, so cover, like, let it be underneath it.
yes, so if I put my finger on top of my gel, about like halfway up my fingernail is buffer solution.
Okay. And it doesn't mess it up to put your finger in it?
No. I mean, I'm pretty stingy on stuff. Even with this, I would have the kids just like rinse their pipettes, but my pipette tips. So, but we'll use all new pipette tips for each of our colored samples.
Okay.
And let me know when you guys are ready to start pipetting, especially if you haven't pipetted before. It's so easy to like jam through the gel. And I could not ever be a neurosurgeon. My hands are not steady. So. And I guess, Megan, let me know when you think. It's hard for me. I can't see everybody's stuff, so I don't know.
Yeah, I haven't seen anybody else. Yes. Rachel, is your gel done?
Yes, I have poured the buffer.
Oh, cool. Okay, yeah. Sorry, I looked away for a minute. I don't know what step we're on.
It's okay.
And I think to go back to the question, there are some labs, I think the highest percent gel I have used is a 2% gel, which is pretty stiff, and it solidifies a lot faster because there's more of the agarose. So, you know, if some people's didn't get all their powder out and things like that, I guess that would probably have a little bit to do with maybe why time is taking it a little longer. And I often have my kids, like, our lab benches are chilly, like they're always a little colder. So you can actually take the flask and kind of like swirl it and scoot it around on the lab bench. And it helps cool the agar a lot faster so you can pour it. You guys ready to pipette? Is there anybody not ready to pipette?
Good.
Mine's still setting, but y'all go on. I'm sure it'll just be a couple of minutes behind.
Okay, are you sure?
Yeah, I've done this in biochemistry in college as well.
Okay,
I've just
awesome.
never done it in a classroom.
Okay. So I guess whichever sample you guys want to use, it doesn't really matter what you use first. But if you look, I always have to get like a weird angle, and then I can see kind of like the silhouette of those wells. You know, because this comb put a little, basically like a little hole, what we call a well. And that's what you want to load the DNA or the dye sample into. So I have mine set at 12. I'm gonna do the purple. Can you guys see? I have to hold it like, I don't know. I have to hold mine at an angle. And I'm
Yeah,
in the
steady.
very left well. And then you can kind of see, if you go slow enough, you can see if your tip of your pipette is like halfway in the well. And then you're slowly, oh, I'm not in the well at all. Okay, I don't know.
So when I took this class, one of the grad students said, if you take a piece of black electric tape and tape it under where the wells are going to be, it makes it a lot easier to see the wells. And so the fact that you're on a black background might be helpful to you.
Yeah, and I can kind of see the wells in her video. But what I usually do too is once I kind of get down in there, I shift back and forth, kind of like up and down on the gel. So you can kind of see that you're tapping the sides of the well, and it'll even kind of shift the gel back and forth a little bit in the box.
So exciting. What color are we doing next?
So I did purple first. I'm gonna do red. And that 12 microliters of purple solution filled about half of my well. So if you guys
Did you
want to
did
add,
you change tips?
I did
Yes.
change tips. And now I'm gonna try to get it in the well again.
Y'all are doing 12s. Just this.
Nice.
And then as soon as that is in, you can get another tip. Pick another color. What color do you guys want to do next?
Might as well do yellow.
I got orange and green. I guess I'll go orange. Get another tip. Do you guys have any questions while we're loading our gel? I find this like the most therapeutic thing ever.
Yeah, that's not therapeutic for me.
Oh, I love it.
So I've noticed that there's, when you put the tip into the buffer, that you have the color spread out just a little bit. Is that normal?
A little bit, and I have a pretty comical gel running with those Flynn dyes that I was telling you about. So I'm happy to tell you that this gel looks better than the one I did in a hurry a couple minutes ago with the dyes. So that when the kid, like the dyes, you'll see exactly what you were saying. The Flynn dyes though are way extreme. It looks like it's I'll show you guys in just a second, but it's all over the place. The dyes kind of like spread around everywhere. And then I'm going to move on to the little tubes that that Megan and Kristen sent. Where is it? These little tubes.
Sure.
If you find that your tubes have like little dots throughout and you might not get all you want, you can like, you know, do the like last of the ketchup bottle. New tip. Do you guys have any questions right now?
So, correct me if I'm wrong, but can't you just use a baking soda solution as your buffer?
I have not used a baking soda solution before. I feel like for maybe something like this, I mean, I'm totally game to trying it out. But if you're using any, like in an AP bio class or something, if you're actually doing some of those restriction enzyme digests, you'd want to use the TAE for the reasons that we talked about earlier.
So just to make my life easier, I'm gonna take the black one and the red one apart. I have two different wires because having them together was a hot mess for me. I was making quite the mess.
I live in high entropy. I feel like these days.
All of us, that sort of sums up this year, doesn't it?
They also just told us that after spring break, we're going back 5 days. So we have been Monday through Thursday, and now we're going back Monday through Friday, which I'm okay with. But I don't know, you know, my seniors, like they probably have work schedules out for the next month, so I don't know. Okay, guys, I'm on my last color and my last well. And I guess as soon as you guys finish loading your dyes, if you have any questions, let me know. But there is a diagram on page 57 on how you're gonna wanna hook up your batteries into like a tower and then get the cords that Stephanie just had out. So the battery, let's see, it's at a negative and then a positive, a negative and then a positive. Ooh. Let me move these cups. It's gonna be a mess.
Yeah, basically just chain them together, positive to negative.
Negative, positive, negative, positive. And then on top, you're gonna go upside down.
Will we be able to wash these tips and reuse them, or do we just throw them away?
I mean, it's just dyes, so yeah, you could rinse it and then reuse it.
Okay. So once you have your power source stacked up and ready to go, you can put your paper clips in the ends. And then we can get my paper clips don't stick out all the way or out. Super easy.
I just made a bend on one end so that there's like one sticking up and then the flat part.
Oh, so you didn't actually put it like this, you just had it like
Yeah,
this?
yeah.
Oh, I lost it in here.
It's drowning.
So go like that. Okay, and then the black, we're gonna put the black, which is the negative, at the top. And I'm gonna totally do what you did, Stephanie.
Yeah, that's a lot better. Things don't move around as much.
The black at the top and on the negative. And then the red at the bottom.
And yeah, make sure your little cover is covering it before you lock it in. This is, so it's 5 9-volts, so that's 45 volts, which is not insignificant.
Do you know that from experience?
I have not shocked myself with this, but I think we had one like gel box that was not quite right, and I definitely shocked myself with that.
And then guys, you're gonna wanna make sure that you see bubbles at this negative end. If you don't see bubbles, then something is not hooked up right and working. I had a poor student run a gel and the chamber was broken and they let it sit for 45 minutes and nothing happened. So just always check for the bubbles. I'll give you guys a little bit of time to hook up your stuff. And Megan said these batteries should last what, like 4 to 6 more times, or?
Yeah, I think it was about 5, so 4 to 6 sounds good.
And once it's running for a little while, I can definitely already see the red dye kind of migrating.
Well, and Trisha, to go with your comical gel that's running, last year I tried it in the kitchen and I didn't have reference dye, so I used food coloring and it was too strong. So it went all over the place. So the reference dyes are diluted, which I think you can do with like corn syrup, just a little bit of corn syrup and water just to give it some weight.
And for those of you that want to see my comical gel, let me see here.
Yeah, it looked kind of like that.
Yeah, the water is totally yellow, and I'm disappointed because I did not pick one that oh wait, I think that yellow one migrated. It had pink. There's like a pink color near my finger. I don't know if you guys can see it.
A little bit. It's very sloshy.
Yeah.
It's up near the top of your.
Oh.
Oh.
There.
Yeah.
Anyways, the dyes are super, I mean, you could probably dilute those with something, I guess. I don't know, but.
So you're only seeing bubbles on the negative end?
Yes. So do you guys have any questions about gel electrophoresis, or are you guys seeing some of your dyes start to migrate?
See a thumb, thumb from Will. Rachel has a question mark and a thumb, question face. Britton's good. Scotty Ann, you good? Awesome. Yeah, there we go. The emoji thumbs.
Okay.
Karen's got it.
Is there anything you guys feel like would help help you make sure that you are good, like making gels and stuff like that for your classes? Or
Yeah, does it matter if we increase the strength of the agarose gel?
it doesn't, like in the world of biotechnology, like if you know that you're going to cut DNA in such a way that you're going to have smaller fragments, you would want to use a stronger gel and then maybe not run it as long, because the smaller fragments are going to migrate the fastest and the furthest. Okay. So like I saved one of my kids' gels. They just ran this and it's a little, oh, I just cracked it. Oops. So this is what one of the gels, see if I can get it, would look like. And they, like right here, I don't know if you guys can see it very well with a glare, but there's like, it's called a ladder. So these are like known fragment sizes. And then these dark bands are actually DNA bands from the mitochondria cytochrome C gene that are about 700 base pairs big, base pairs long. And so they migrated, and we use the ladder because then we know that they match where that 700 size should be. So depending on what you're using, you would use, if you know you're going to have really large fragments, then a 0.8% gel or a 1% gel is perfectly fine. Like I said, I feel like they're the most commonly used, but 2%. But anything more than a 2%, you know, stuff just, it solidifies so fast. It's hard to start to pour them out. Or maybe it was a 3%, like it couldn't cool fast enough to pour it before it started solidifying in the flask. I don't know if that makes sense.
It does. It does. Just mine never really got very, very solid for it with the 0.8%. So like if I did 0.8% and just left it overnight before we used it.
Yeah, I mean, I feel like a 0.8 and a 1%, I mean, it shouldn't take, I mean, depending on your class time, your class block class, or, you know, like how long they are, you definitely want to have them made the day before, because it could take 30 minutes from start to finish. And then if you have your whole class sharing one microwave, that's also not ideal. So.
Okay.
Do you guys have any other questions about gels?
So I'm watching mine run, and I'm not sure if it's that I bent my paper clips wrong, but it almost looks like my paper clip is kind of melting the gel. I'm not sure if it's just because it's pressing hard against it, or if it's actually melting the gel.
I think it's melting it a little bit.
Okay. I assumed there was a little bit of heat with it, but I struggled with my paper clips. I hope I wasn't the only one.
Mine don't look super pretty.
Yeah, it's not exact. So
But
So
I'm sorry, go ahead, Stephanie.
I got this stuff that's called agar powder, and I use it for the cell diffusion, cell size lab. You know, how much is too much or how big is too big. Could I use this stuff that Terry, right? Can I use this as agar powder?
So I feel like that would be more of like maybe bacterial growth media. I would need to double check the ingredients of agar versus agarose.
Okay.
So I can look that up tomorrow if you want, and we can email.
Okay.
Do you put the phenolphthalein stuff in your agar cubes?
So I used BTB this time.
Ooh.
And it was the kids stinking loved it. And I used BTB because that's what I had. And you don't have to make a really strong solution. Like I put like a little dusting in 500 milliliters of water. Like I really didn't make a lot, didn't put a lot in there. And that was enough because as soon as you put it in the vinegar solution, then it's going to start changing colors. And like it's pretty quick. And then if you get, like I use a half a centimeter and then a long skinny one. And as soon as you drop it in there, you start seeing a difference as it moves inward. Kids really like it.
So was the solution blue or was your agar squares blue?
The agar squares are blue.
Okay.
And then
Cool.
you can, so I haven't tried it with, I diluted the vinegar. And so that might've made it a little bit slower, but like they really like it. And it's stuff like, unless they eat the agar cubes, they're not going to hurt themselves with it, you know? So right. I don't feel like they use masks and the gloves that Megan got for us. We've been using them and I make them use lab aprons and all that. But I feel like if you're going to do a lab with chemicals, you know, that one's okay. And then we just double bagged it at the end of the day, put it in the trash. And if that was wrong, don't tell anybody I did it.
That sounds awesome. Yeah, that BTB, that's genius. I'm totally doing that the next semester.
Yeah, and it just takes the little bittiest bit. You know, phenolphthalein, that stuff, you know, that used to be the main ingredient in X-Lax, right? That was the business end of X-Lax. And so you get too much of that or you get on your skin or something, I don't want to be responsible for somebody spending the evening in a bathroom.
Right.
They put my phenolphthalein in like dropper bottles so that I can control, there's no dipping into it or anything like that. So for me, that works out better.
Okay. Well, do you do the cell size lab? Is that what, because that's what I was talking about. So I feel like, because it really doesn't take that much of the BTB. And like this, I made enough for all 4 classes. And I still have probably 80% of this bottle left. So it's going to last me a while.
That's awesome. Is everybody seeing their stuff migrate? I just want to double check. Okay. And then Megan, I don't know if there was anything else today or what.
No, so the main thing next week, we won't have any labs. We'll have a speaker and then you guys will be doing some planning for your implementation. So basically a discussion of what lab you want to implement and then where you're going to fit it in your curriculum. So you guys can share ideas about that and kind of brainstorm and bounce back and forth off of each other. So the materials that you'll need is basically just anything curriculum related. So if you have your calendars, your planners, your standards, all that good stuff, just come prepared with that to use it. and come prepared to brainstorm.
Do you guys have any other questions or need anything today?
Nope. I will see you guys next week then.
Have a
Sounds
great
good.
Wednesday and rest of your week.
Thanks, guys.